So here we need to state whether if the following statements are true or false. Let's begin with the first one. So here we are given two vectors. One is denoted by A with an arrow sign on top of it, and then we have another vector with a bar on top of it. This is a trick question. Actually, they are both the two same vectors. This is just a different way of representing a vector. We can also use a scalar number, and on top of it, if we place a bar, that was also going to represent a vector. Sometimes we use an arrow, so sometimes we use a bar. Now these two vectors, since they are equal to each other, we know that two equal vectors are always going to be collinear. Therefore, the first statement is going to be a true statement. Coming to the second one, two collinear vectors are equal in magnitude. Now, is this a true statement? The collinearity only has to say something about the parallel support. So that means, let's say we have a vector A, and I'm going to consider another vector B, slightly longer than A, which means that the magnitude of the two vectors are different from each other. However, they're both pointing in the same direction. Since they're both pointing in the same direction, so what we can do, we can pick the vector A and place it on top of the vector B. So let's do that. We are simply displacing vector A. Now clearly, we can see here, if we draw a straight line or passing through each of the two vectors, or we can say if we draw a straight line, both of the two vectors are going to coincide with this line. That means it's going to lie on this line, suggesting that they have the same parallel support. So here we can say that vector A and vector B are collinear. However, because they don't have the same magnitude, we cannot say that two vectors that are collinear are going to be equal in magnitude. So that means our second statement is going to be a false statement. Now, the third one is very important. Zero vector is unique. Is this a true statement or a false statement? So what we'll do, we'll try to prove this with the help of a contradiction. Let's say we have some space which contains different types of vectors. So here we're going to pick up a vector which is referred to as the zero vector. The zero vector means a vector which is dimensionless. So if we want to think in terms of the unit vector, so let's say we have a vector which can be represented in terms of its unit vector as 0 I cap plus 0 j cap. We're only considering two dimension for simplicity and understanding. So here we can see here that the x component and the y component of this vector is 0. That's why it's a zero vector. Now, the property of zero vector is only valid for its addition. That means it's an additive identity, which means if we take a vector A and then we add it with the zero vector, so that's going to give back the vector A. That's why 0 is an identity. Zero vector is an identity. However, let us suppose that this statement is false, that zero vector is not unique. That means there consists another vector. We are going to call it 0 prime. And this particular 0 prime, since this is also another kind of a zero vector. So this property is also going to hold true, that if we take a vector A, add it with this other zero vector, which we are calling a 0 prime vector, that should give back the vector, original vector A, because this is an identity. However, since A vector equals A vector, what we can say here that A vector added to 0 vector, this must be equals to A vector added to 0 prime vector. Now what we can do, you can cancel out A vector from both sides, and we're getting the case that 0 vector equals to 0 prime vector. That means actually they are both the same vector, which means that it is a true statement that 0 vector is a unique vector. So our third statement is going to be true. Coming to the fourth one, so here we have two vectors having the same magnitude are collinear. It's only saying the two vectors that are having the same magnitude are collinear. This is not necessarily a true statement. For instance, we can think of a vector A pointing in this particular direction, and we have another vector B pointing in a completely different direction. Let's say the magnitude of vector A equals to the magnitude of vector B. Now, by no means these two vectors are collinear. That means they don't have the same parallel support. So in this situation, we can say that two vectors, even though they have the same magnitude, we cannot say that they are collinear, which means that statement number 4 is a false statement. Coming to the fifth one, we have now two collinear vectors. They have the same magnitude. Are they equal? Now this is a slightly tricky question. Okay, so here we have, let's say, a vector A, and we have another vector B, let's say, which also has the same magnitude as vector. So it also follows that the magnitude of both the two vectors are equal. Now, are the two vectors collinear? Definitely, they are collinear because we can think of it as, let's say we have a line and we can pick up both the two vectors and place it on the line, and they are going to lie on top of the line. That means they have the same parallel support. So here, we can say that the two vectors, they are of equal magnitude, they are of they are also pointing in the same direction, they have the same parallel support. So these two vectors seem to be equal. So all they are saying, the two collinear vectors having the same magnitude are equal. Okay, so this might seem true in this particular case, but there is another scenario. What if the two vectors are anti-parallel? That means we have a vector A pointing in the other direction to that of B. Now clearly A vector and B vector both have the same magnitude. So here we're considering negative A vector. Let's call it this negative A vector. If we take its magnitude, let's say the negative A vector has the same magnitude as positive B vector. Fine. Are they collinear? Definitely they are collinear, because we can consider the parallel support on top of the parallel support. We can place both of the two vectors. We can place negative A vector as well as positive B vector, and they are collinear to each other. So these two vectors, they have the same magnitude, they are collinear, but they are not the same vectors. They're completely different vectors. They are opposite to each other. So it is not necessarily true that two collinear vectors having the same magnitude are equal. So in this specific example that we took, if we take two anti-parallel vectors but having the same magnitude, they are not going to be equal.